All right, our next passengers on the success train are going to be those loopbacks. And I'm going to do a quick show config on each one of these. I knew we were missing one. 55. That being, of course, a host mask. And we're also going to use, network command here. Now, let me ask you, there's a huge hint on here, of course, as well. What wildcard mask do I want to use if I only want to enable EIGRP on this one single interface? And the hint is the mask I just put on the IP address, 1111. So you see the mask of 255 for each octet. We know a subnet mask is a wildcard mask is an inverse subnet mask. So this is going to be all zeros. Go ahead and introduce that one. Let's check 2 here. There we go. And router 3. So far, so good. Okay, so I had 2 out of the 3 loopbacks ready to go. That's a pretty good percentage. You know, I guess I can keep the gig. So let's see. We've got the loopbacks in there. Let's go ahead and put the Ethernet segment in there while we're at it. And we had a /27 mask on that particular interface. /27. If I want to tie that down with a wildcard mask, what's the mask going to be? What is the wildcard mask going to be? If I want it to be the inverse of a /27 subnet mask, that means the last 5 bits in it are going to be 1s. Our wildcard mask, the last 5 bits are going to be 1s. Everything else is going to be a 0. So that's going to be 000.31. Right. That's it. So let's head up to router 1. First, we'll take a look at the EIGRP route table. At this point, you can see there's that letter D, and we know what that's all about now. And we've got 1 entry for router 2's loopback, and you can see the next hop is .2, which makes sense. Router 3, we have 1 entry for router 3's loopback, and the next hop is .3, but we have 2 entries for the Ethernet segment. That's a little interesting. Well, the reason that we saw in the previous discussions is that this metric is exactly the same. Remember, the first number in the brackets here in the routing table is going to be the administrative distance, and the second number is going to be the metric for that route. So let's see, how could we see if there are any feasible successors? We know these are the successor routes. It's show IP route topology. You knew that one, it's show EIGRP topology, so you probably knew it better than I did. So we've got all kinds of entries here. And for the 172.23.23.0/27 entry, 2 successors, we know why. The feasible distance for both is exactly the same. So far so good, and connected, of course, we've enabled EIGRP on it, so it's going to show in the topology table. But we know that's a connected route, router 1's loopback, as well as the subnet network. But we have 2 entries for each of the loopbacks on routers 2 and 3. But we only had 1 entry for each one of them in the route table. So we also know that we only have 1 successor because, by golly, it's telling us that right here. 1 successor, 1 successor. Now, why exactly is that? And we know it's the feasibility condition. Why is it in here but not in the route table? Well, that's because this route right now is considered a feasible successor because its RD, the second number in the paren, is smaller than the FD of the successor route. Same goes with router 2. We see the entry through .3. The reported distance is 409,600, and there's the feasible distance. So what path exactly is that taking? Let's step back and take a look at our network, because right now we have 2 routes to router 2's loopback from router 1. We could go straight through the cloud to router 2, or we could go through the cloud to router 3, then through the Ethernet over to router 2, and then to the loopback. That's where that second entry is coming from. Now, that's a valid route. It's loop free, and that's what EIGRP has detected. But it's also detected, hey, it's a lot better metric for us just to go through this frame network, the main network 172.12.123.0. It's quicker to go through there than to go through the same network to router 3 and then through this Ethernet segment to router 2. So EIGRP is pretty bright. It's already seen that there are two possible paths there, and it's already picked out the best one, and we know why they are not in the routing table. And of course, the same is true for router 3. To get to router 3's loopback, we could just go through the 172.12.123.0 network straight to router 3, or we could go through the same work to router 2, then through the Ethernet, and then over to router 3. The key here is that if one of those links fails, then the good news is we already have our backup routes ready to go. So that backup route would be put in really almost immediately. Now let's go back and take a look at these metrics, because what we have here, let's look at these feasible distances. Here are the feasible distances for the path to router 3's loopback, and those are pretty close, relatively speaking. They're pretty close. Same thing here for the two paths to router 2's loopback. Now, what we could do is perform unequal cost load balancing here, because we know equal cost, and we're seeing that in action on the path to the Ethernet segment. We know that's only going to happen when these FDs happen to be exactly the same. Well, you could have situations, and I guarantee you in labs and production you will have real-life situations where these FDs are real close to each other, but trying to tune them to be exactly equal, just forget it. We could tune the bandwidth command a little bit, maybe work with the delay, but trying to get these two the same, it's just not time efficient. Instead, what we could do is work with a certain command that helps us to enable unequal cost load balancing. Let me show you where that is. Actually, I'm going to add this shot to the book. I don't have this command in the EIGRP section, but I'm going to add it. Here's where you can find the variance command, or the variance value, I should say. Now, EIGRP maximum metric variance 1, when I explain to you here in a minute what the variance command is, the explanation sounds kind of long-winded, and I'll try to short-wind it as much as I possibly can. But when you see it in action, you go, oh, it's one of those things where in text it sounds complicated. Then when you see it in action, you say, well, that was easy. This is 1 by default. And what it does when it's set to 1 is it is enabling equal cost load balancing. That is enabled with EIGRP by default. But when we change the variance value a bit, we're going to be enabling unequal cost load balancing. Now, the extent to which that balancing is enabled is up to us, because unequal cost load balancing, not all configs are alike for that, believe me. And we're going to see that on the very next video. Also, a couple things here I'd like to point out. Automatic network summarization is not in effect. That's because we put the no auto summary command in each one of our configs. If we had left that out, the magic word not would not be here. You can see the routing information sources that we have right now. Where are we getting routes from? What are the distance of the routes we're getting? And when was the last time we got an update? Notice at this point, it's been 4 minutes, 48 seconds since we got an update, which means we're not getting an update on a regular basis from EIGRP. That's what we want. We know that at the beginning, when they form an adjacency, they exchange full routing tables. After that, they're only going to exchange updates when there's an actual change in the network. We also see the distance, and notice it doesn't go all the way and say administrative distance, but that's what that is. We talked about that in the last video. You've got internal 90, external 170. This is a great command. It really does give you a lot of good solid information about whatever protocols you're running. So in the very next video, we will talk about the variance command for a few minutes. We're going to do a little math, so keep that pencil and paper handy, and then we will see it in action in our network. See you there.